Hi friends, good evening. Today let us start our first unit of problem solving using C. In this series of lectures, I'm going to tell you mainly the theory part. Once we complete the theory, then we'll go for solving the problems or writing the programs using these concepts. So starting with the first unit, problem solving using C, the first unit is Introduction to C Programming. So as you can see, in the first unit, we are going to discuss about the basic components of a computer system. Then we'll discuss how to create and run a program. Then we'll learn about what is an algorithm, what is a flowchart. Then we'll discuss about what are variables, what are different data types in C. This is our first unit basically. Now coming to the introduction part, as you all are aware, what is a computer? So you know that a computer is an electronic device. What it does basically, it takes input from the input devices, it will process the data and gives us the output. So this is nothing but basically a computer. Now, generally a computer system, we classify a computer system into two categories, hardware and a software. Coming to the hardware, hardware means the physical and the electrical components which we can touch and feel. So they come under hardware. Coming to the software, so these are a set of instructions. You can feel them but you can't touch them. That is nothing but a computer software. So basically we classify a computer system into software and hardware. Next, components of a computer system. Coming to the components of a computer system, we have input devices, central processing unit, output devices, and storage devices. Coming to the input devices will provide the input data to a computer. So input devices are, best example for the input devices is keyboard. Next, coming to the central processing unit, CPU is known as the brain of the computer. So it has three parts basically: arithmetic logic unit, control unit, and memory unit. We also have different storage devices, and then we get output, or we'll see the output with the help of output devices. This is basically known as computer architecture. Coming, as you all know, what does the input devices do? Input device will provide the input data to a computer. So the best example for the input devices are keyboard, mouse, scanner. These are all known as input devices. Coming to the CPU, as I have already told you, this is the main part of computer, and the main function of CPU is it will execute the programs. So as I already told you, it consists of three parts: arithmetic logic unit, control unit, and memory unit. Coming to the arithmetic and logic unit, what it does is it performs arithmetic and logical operations. Arithmetic operations include addition, subtraction, multiplication, divisions. So these operations are performed by ALU. Control unit will control all the activities of a computer. Coming to the memory unit, it will hold the data which is to be processed. So as we started our discussion about memory, generally there are two types of memory. As normally we also have, right? We say mine is a short-term memory, my memory is a long-term memory. Like in the same manner, we have two types of memories: volatile memory and non-volatile memory. So what does a volatile memory mean? Volatile memory means if you switch off the computer, or if you switch as soon as the power is switched off, whatever the data is present, it will be lost. if the information present in the devices is lost as soon as the power is gone, it is known as volatile memory. Simply in terms of to make you understand, I'll tell you, it's like temporary. Or best example I can give you is, in a class when a teacher says go on saying something, we'll listen to that. After coming out of the class, most of us will forget them. It is nothing but the volatile memory. Coming to the non-volatile memory is, even though the power is switched off, the information which is present in these devices will not be erased. Such type of memory we are going to call it as non-volatile memory. So as we are discussing about the memory, we have to know how this memory is being stored, right? So we'll see about the different kinds of storage devices which we have. Coming to the storage devices, we have four kinds of storage devices: primary storage or main memory, secondary storage or secondary auxiliary storage, cache memory, and registers. So as you can see, this is the types of storage devices. Main memory consists of RAM and ROM, secondary memory, cache memory, and registers. I'll explain you this memory with the help of this flowchart. So main memory basically consists of RAM and ROM. You know, RAM is random access memory and ROM is read-only memory. And second, in this main memory, the data is stored temporarily, or the data is brought from the secondary memory during processing to the main memory. Next, secondary memory will store the data permanently. Example is disk drives, hard disk, etc. Coming to the cache memory, this memory is located in between the CPU and main memory. So it will be like processing of cache memory will be faster. Next, coming to the registers. Registers are the small memory units. These are present inside the CPU. So these are the different kinds of storage devices that we have. So main memory consists of RAM and ROM, secondary memory, cache memory, and registers. Now these are all the points. Okay, so as I have told you, under the main memory we get RAM and ROM. RAM is random access memory, and we all know it is a temporary memory and it's a volatile memory. ROM, read only memory, it is a permanent storage medium, it's a non-volatile memory. Next, coming to the secondary memory, the data will be stored permanently. Cache memory is a memory between CPU and main memory, and it's a volatile memory. Registers are small memory units that are present in the processor. Coming to the output devices, as we all know, what is a basic function of a computer? It takes input from the input devices, it will process it and gives us the output through the output devices. So what are the output devices? Output devices, the best examples are monitor, printer, and plotter. These output devices will show us the result or displays the result. Now, my main question is, for example, you are a Telugu person or you are an Indian, and you have to talk to a Chinese client. Okay, so you don't know Chinese and he don't know any of the Indian languages. Now there is a problem of communication, okay, between you and him. Then you need a person who can act as a mediator, who knows both Chinese and Telugu, who can tell your views to him and his views to you. In the same manner, just like an interface, we also have an interface that is known as OS or operating system. So it will be acting as an interface between a computer user and a computer hardware. It's basically an interface. As I have told you, when you don't know his language, you need some mediator who can tell your views to him and his views to you. In the same manner, we have an interface between computer user and computer hardware that we call it as operating system. So along with the acting as an interface, operating system also has various works to do. So those works are, it does file management, memory management, process management, device management, etc. These are all the various tasks that an operating system will do. So whenever we talk about a programming language, the main thing which comes under in our mind is how to write the programs, right? So generally, when we want to create and run the programs, we have 4 different steps for it. The first step is, first you have to write and edit the program. Then you go for compiling the program. Then you use the required library functions, and then you start executing the program. So these are the 4 steps in order to create and run a program. Now let us see, I'll tell you. So generally, whenever we want to write a program, we use different kinds of text editors. So when you write a code or a program in a text editor, we call that code as source code. When after compilation, the source code is converted into an object code. Once we link this object code with the required library functions, we get executable code, and after running this code we get the result. So this is the main process that happens while writing and running the programs. As you can see, we use different kinds of text editors to write and edit the program. So the program which you write in the text editor, we call it as source file, and every programming language has its own extension. In C, we save the file with a .c extension. In Python, we save the file with a .py extension. So this file we call it as source file. And the major point which we need to discuss here is, as we all know, compiler. What does it do? Basically, everyone says that compiler will convert high level language into the machine level language. But along with that, compiler has one more task to do. What is that? It also acts as preprocessor. So compiler has 2 different tasks, that is preprocessor and a translator. So now what is a pre-processing means? The name itself suggests that before processing is done by the CPU, the processing is done with the help of compiler. So how does this pre-processing done? So as you all might be aware that when we write a program, we write hash include stdio.h, right? So this hash, we call it as preprocessor command. So whenever a compiler reads the source file, it will check for this preprocessor commands, then it go for pre-processing. After the pre-processing is done, then it will convert the high level language into the machine level language, that is nothing but translation. So the 2 tasks a compiler does is preprocessor and a translator. Next, the third thing, as I have told you, after writing the program and after compiling it, we'll use the required library functions. For example, if you are writing string, you need to add string library, hash include string.h. In the same manner, if you are using math functions like power, square root, truncate and all, then you have to use hash include math.h. Depending on the functions which we are using in the program, we include the library functions. So once we link a program with the required library functions, it becomes the executable code. Then with the help of loader, we execute the code and we get the result. These are the 4 steps that we need to do in order to create and run the programs. So the 4 steps are writing and editing the program, compiling the program, linking the program with the required library function, and executing the program. I hope it is clear for you. Now we'll go with the next topic, that is algorithm. So I want you to understand this in a very easier manner. So algorithm, what is an algorithm? Now I'll tell you, if you want to do some thing, or I'll give you a best example. You are going to a new place, okay? You don't know the direction of the place exactly. Then what you do is you ask someone to tell the direction, and you will take right, then go left. You write it in a specific order, or you remember it in a specific order, so that you can reach your destination. In the same manner, whatever instructions we want to give to a computer to do a specific task, we write it in an ordered manner in a clear way so that the computer will understand it and will complete the task in a given time. So that ordered sequence of clearly and well defined instructions which will perform some task, we call it as algorithm. So we define algorithm as ordered sequence of unambiguous and well-defined instructions. It will perform some task and it will stop it in a finite time. So as the definition itself suggests, we have four things in the definition. First thing is ordered sequence. Ordered sequence means you can number each and every step. Step 1, step 2, you can write. Unambiguous and well-defined means each instruction must be clear. And we already know that a computer is similar to a small baby. It will blindly follow whatever instructions you give. So the instructions which you are giving, they must be clear and it must be understood without any kind of difficulty. Next, it should, with those instructions, the system must perform some task, and once the task is performed, the algorithm must stop. So this is about algorithm. So I'll show you one example for this, then we'll go for the other. Okay. So you can see here, whenever we want to write an algorithm, you have to write start or begin and you have to write end. Start and stop, they must be there. Okay. So step 1. For here we are writing algorithm to find whether a given year is a leap year or not. So in order to find that, what will be the step 1? First you have to take the year. So accept the year. Now my condition is, if year percentile 4 equal to 0, then you have to print it is a leap year. Else you have to print it is not a leap year. So this is stepwise ordered sequence, okay, with clearly defined instructions which perform some task, we call it as algorithm. I'll show you some more examples. The best example is, you can see here. First you have to write start. Step 1, accept a comma b. Step 2, c is equal to a plus b. Step 3, print c, and end. This is an algorithm to find addition of two numbers. Okay, so that is about algorithm. While discussing about algorithm, we have some properties for an algorithm. The properties are finiteness, definiteness, effectiveness, generality, input and output. So in the next session, we are going to discuss these properties of an algorithm and we'll see what a flowchart is, and then we'll go for some examples in the next session. So until then, keep watching our channel for many more interesting topics. Please like, share our channel, and don't forget to subscribe our channel. Thank you for your patience, and if you have any doubts in any of the topics, you can please mention them in the comment section so that I'll make videos on those topics also. Thank you everyone.